live, hopefully. I'm gonna just chill for a little bit and make sure that the stream has caught up with me. Meanwhile, hello Kagglers. Welcome to another stream where we're gonna do live coding because it's Friday. Sorry, I've been having weird allergies this morning, so I took antihistamines and I'll be fine, but also maybe a little bit loopy. Get rid of that. Okay. We have been, for a while on the channel, learning about different types of AutoML. So we did we read the paper from the first benchmark a while ago, and we talked with Kaggle, who's an AutoML researcher at Google, and Aaron Liddell, who's an AutoML researcher at H2O.ai. And at Kaggle Days in March of this year, there were some talks about AutoML and different systems that people tried out. You may have noticed on some competitions there's an AutoML benchmark. And the sort of, that's not sort of, AutoML has gotten to the point in maybe like the last couple years where it's actually kind of good. I don't want to be like, oh, it sucked before. We're just getting to the point where it's viable, I think I would say, where the systems are good enough and robust enough that you could start to think about using them in production. And I have not messed around with them yet. And I'm just real curious, especially since a lot of the papers that we've been reading, even the ones that aren't about AutoML, have an AutoML component, particularly with regards to neural architecture search. So the weight agnostic neural networks that we read about, the second to last paper, the whole idea of the paper is, hey, instead of training the neural network, we're going to find a new architecture that works well for a specific problem, which I would say is a type of AutoML. And then for the last paper we read about EfficientNet, the family of efficient nets, we're still reading it. We haven't finished reading it yet. Emerged from this neural architecture search, AutoML research. And I am interested in, kicking the tires, see what the fuss is about, see how viable it would be for like my day-to-day tasks, which would not require neural architecture search. Hello, everybody. Enrique, Abhishek, Ravi, welcome. A little sip of tea. BLS is, if you are wondering, Berkeley Linguistics Society, and it's got a bunch of like linguistics nerd stuff on it from back in my linguist days. All right, so the reason that I have this up is because I think this is a really nice collection of the open source AutoML options that are out there, and there's a bunch of ones that you can pay for. So H2O.ai has a free one. They also, not free, an open source one. There's also a proprietary version you can pay for that does slightly different things. It's a little bit more hands-off. DataRobot has some, Google has some, of course. I'm sure Microsoft and Amazon have some, and I just haven't messed with them any. This is a good list to get started with about what's out there. And the ones that I am most interested in, for me, just after like looking into them a little bit, AutoSKLearn. So this is designed to sort of work with the existing. So it creates scikit-learn pipelines, which are an object from scikit-learn, and automates that process. So if you're already using scikit-learn, this should be a fairly simple, like, plug-and-play substitution, in theory. AutoWeka is in Java, so I'm not going to mess with that. H2O AutoML is actually has a backend in both. Sorry, it has a front end in both Python and R. So whichever one you prefer, you could use. And that one I am interested in. TPOT, I know is probably among the more popular libraries on Kaggle. I think, I would guess that TPOT is probably actually the most popular library of these ones that are listed on the screen on Kaggle. And I'm also really interested in AutoXGBoost. So XGBoost, if you're familiar, is a gradient boosting library for producing random forests, which are a type of ensemble model made up of trees. And AutoXGBoost automates the XGBoost process, apparently. And it seems very interesting because I like XGBoost as an algorithm, and it would be great if I didn't have to do my own tuning. That would be nice, because I am inherently lazy. So those are the ones that I want to play around with. And my gut instinct is that it's going to be pretty hard to get these, to get anything that's not already installed on Kaggle kernels up and running on Kaggle kernels. So I'm not going to promise that we're actually going to get anything done today. But I do have a problem in mind. And the problem, a little sip of coffee, is, show me the data sets. Data science, I think we'll get it to it. Data science bowl, no. I want the 2018 one. There we go, yeah. So the problem that I thought could be interesting is we have this data science survey, and we're currently running the 2019 one, so if you haven't filled that out yet, add your data. Be counted. And the link to that is on our Twitter, is probably the easiest way to find that. Or you might have gotten an email. And the survey has information on a number of things, but something that I think could be helpful is that we have information on people's titles, and then also a number of other pieces of information like highest educational attainment, industry, years of experience, compensation, how the employer is using ML, their roles, so what are you doing at work? And also the tools that people are using, and this is all information on tools, the IDEs people use, that's all information on that, cloud services, programming languages, ML frameworks, etc. And what I thought would be helpful as a sort of service to the community, and also I'm just want to know, is given these pieces of information, so given, let's say, a salary band and highest degree of educational attainment and like a selection of tools, can we guess what the job title should be? So this would be helpful for someone who wanted to hire somebody working in machine learning, and they're like, okay, I know I want somebody who has cloud experience and has, let's say, a master's and business background and knowledge. What would my job title be for that person if I want them to, build pipelines and then analyze data and then present the results? Like, what should I call that? How am I going to be able to reach that audience? So that was my idea. People saying H2O is pretty good, and they like it. Yeah, I've only, I don't think it's here. I have like a little book about the H2O AutoML, the open source one, and I read it and it looks good, and that's where I am on that. I haven't actually used it. So, Boom says, why do I have to fill my data in the survey? Can't you just predict it? No, you know as well as anybody that good results depend on good, clean data, and ideally lots of it. All right, so that was my thoughts. I'm trying to decide what system I want to start with. Maybe TPOT. Let's see if anyone has kernels. Well, first thing, let's start a new notebook. And then let's see, Kaggle, TPOT. Let's see if anyone has already, there we go, has already written some kernels using TPOT, because that's probably going to be the easiest for me if I can fork an existing kernel. And it looks like this is also information on how TPOT works. Okay, so what does TPOT actually do? And this, again, is just like one AutoML system, and there is lots of them. So it takes raw data. You do the data cleaning, which I think is fairly standard. I don't think any of the major AutoML libraries will actually do all of your data cleaning for you. I think you usually do need to do that by hand, because it requires a deep understanding of the data set and your questions and your goals. So that is something that, you gotta get a human to do. And then what TPOT will automate is feature selection, feature pre-processing, and feature construction. So making new features based on your existing features, applying transformations to those features, and then picking the ones that are good. Trying multiple selections and picking the best one, and then for that model, optimizing parameters. So it looks like model selection is done before parameter optimization. So I'm wondering if this is actually sort of like a loop, or if this is done concurrently across many different models. And then model validation you have to do to make sure you're not overfitting. So it's in Python, and you can have it running, it looks like, for quite a while. You could try early stopping, and then it provides you with Python code for the best pipeline it found, so you can tinker with the pipeline from there. Okay, that seems very useful. It's a high-level library built on top of NumPy for numeric processing, pandas for data frames, TQDM for alerting and like messaging, scikit-learn, DEAP, I haven't used that before, I don't think, etc. So it's easy to learn. And you can enter multiple copies of the data set into the pipeline for analysis, modify the features. So here we're doing dimension reduction, here we're doing polynomial combinations of features, it looks like, and then combining them. Recursive feature elimination, so that would be like I feel like that's one of the things statisticians get angry about, but that might be specifically for the regression family models and maybe not for machine learning in general. And then final classification is performed on the final feature set. Okay, and so random forest, and then polynomial features, and then PCA here would all be learned. That these are the things that you would want to do. All right. And it's it's a genetic algorithm. Okay, so it's very similar to the, if you were here for the weight agnostic neural networks paper, very similar. You generate a bunch of candidates, you evaluate them, you get rid of the bad ones, you keep the good ones, you generate more candidates based on those, you evaluate them, you drop the bad ones, you keep the good ones, etc., etc. So you're sort of evolving towards a given endpoint, where the endpoint is based on your particular metrics. And it looks like this takes... I don't know if this is per epoch or total amount of time. It looks like this is total amount of time, maybe. So it looks like it takes like 2.5 minutes to run 6 generations. Okay, and then you can export the pipeline. All right, so let's try copying and editing this. And actually, I don't want this notebook. I want to go back. Whoop, back to the Kaggle survey. All right, so let's see what's in here. And I'm probably going to delete a bunch of the text cells. Like I said, TPOT is just one tool, and I would like to try multiple different tools and see which one works best for this particular problem. Because one thing that I think is increasingly clear to me, at least based on the research that's coming out of the field, is that different AutoML tools work better for different types of problems. So if you were here when we read the OpenML, AutoML benchmark. Ooh, is it from OpenML? I know OpenML does do benchmarking, but I'm not entirely... maybe the AutoML was on the OpenML datasets? I don't remember. Anyway, when we read that paper, it was pretty clear based on the results that what model worked best really depended on the specific it really depended on this specific question that you were asking. Right. All right. A little bit more coffee. I'm getting it everywhere. Sorry, I mentioned I took antihistamines. They usually make me a little bit loopy, so hopefully I can keep it to a dull roar. All right. And I do want the documentation in a new tab, please and thank you. It does look like it's Python only. Some of the other tools are R only, and I think like Weka's Java only. So what language you prefer to use is definitely going to be a feature. All right, so it looks like there's two APIs you can use. One is for classification and one is for regression. Okay, excellent. We are interested in classification, so this is the one that we're going to be using. So generations would be the number of iterations of going through. Population size would be, I guess, the number of candidates you generate at each generation would be my guess. Rachel, it's right there. Number of individuals to retain in the genetic programming population each generation. Nailed it. Offspring size none. Why don't we just read through here so we know what these parameters are. Number of offspring to produce in each genetic programming generation must be a positive number. You can't produce negative children, noted. By default, the number of offspring is equal to the number of population size. So you do, so every generation you'd double your population and then only keep the top half is what I'm understanding from this by default, and you could tune these. Mutation rate is, so this would be sort of similar to the learning rate. It's sort of like how much you move in each iteration. This parameter tells the genetic programming algorithm how many pipelines to apply random changes to every generation. Crossover rate, how many pipelines to breed in each generation. Scoring. Okay, so these would be the metrics you can use, and it looks like they've got quite a few built in. So accuracy, adjusted random score. Don't think I've heard of that before. Average precision, balanced accuracy, F1, F1 macro, F1 micro, F1 samples. So based on a sample of the population rather than the whole population, F1 weighted, negative log loss, precision, macro, micro. I'm not sure what the difference between these macros and these micros is. It might be on only, I guess, the current generation versus all the, I have no idea what the difference is there. Precision samples, precision weighted, recall, macro, micro samples, weighted, and then return operator characteristic area under curve. And that's the sort of like that. Oh, I guess from your perspective, it's like that. There you go. Mirror image. And you can also pass in a custom scorer using this scorer function. So that is helpful. And then there's more information on the scoring functions. Includes a cross-validation strategy. So you can specify K for stratified K-fold validation. An object to be used as a cross-validation generator, or an iterable yielding train test splits. So it looks like you have quite a few options here. Subsamples. Fraction of training samples used during the optimization process must be between 0 and 1. You can choose to use a random subsample of half the data. This subsample will remain the same during the entire pipeline optimization process. Okay, so this is how much of your data you want to use to optimize. Akash says, hi Rachel, what do you think about H2O driverless AI? I will say I have not used it, but again, it seems that the current consensus is that different systems work better for different problems. I know there's a lot of very smart people working on it, and yeah, I haven't used it, but from what I hear, it works very well for some problems. I mean, that's just like, that is my honest opinion. I'm not trying to like be frustrating. I know it's very much like an it depends sort of answer, but it depends. Right. Number of jobs, number of processes to use in parallel. Okay, so this would be if you were doing multi-core stuff. Maximum times in minutes. Okay, so this is nice. You can be like, hey, no more than 10 minutes. I gotta like get a snack and then come back, and I want it to be done by then. Maximum evaluation minutes, so how much time minutes TPOT has to evaluate a single pipeline. Setting this parameter to higher values will allow TPOT to evaluate more complex pipelines, but will also allow TPOT to run longer. Using this parameter to help prevent TPOT from wasting time on evaluating time-consuming pipelines. So maybe if you had a transformation that just takes a really long time, this would help you avoid that. Random seed for reproducibility, so a dictionary that you could use to do configurations. So this would be if you were going to try doing parameter search on doing hyperparameter search for AutoML, you could save a dictionary of the parameters you were interested in and then just pass it in programmatically. Template of a predefined pipeline structure. This option is for specifying a desired structure for the machine learning pipeline evaluated in TPOT. So far, this option only supports linear pipeline structure. Each step in the pipeline should be a main class of operators, selector, transformer, classifier, or a specific operator. Okay, so this is like if you know that you have, you're going to have to do some sort of transformation and then classification and then selection. I don't know why you do it in that order. But if you have that maybe you need 2 transformation steps, you could specify that here. Warm start, whether you should reuse the population from previous calls to fit. So this would do nothing the first time you run it. But the second time it would let you know, it would be like, hey, use the stuff you did last time. A job lib. If supplied, pipeline will cache, or cache if you're Australian, each transformer after calling fit. I don't believe this is a transformer in the neural network sense. I think this is just like a thing that transforms. I believe TPOT predates transformers as models. I think. Use Dask, periodic checkpoint folder, early stop. How many generations TPOT checks whether there's no improvement in the optimization process. Verbosity, how much information you want. And then disable update check. And then we have, Windows wants to restart. No. And then other information. And then here we have a little, minimal example, and then once you have created your classifier, you can fit it, you can predict it, you can use it to predict class probability. So if you want to do some sort of softmax yourself, you could do that. You can use it to score the pipeline giving some testing data, and then you can export it as Python code. I think this is probably the thing that I am most excited about in this library, that it does give you just like a pipeline out that you can use. I mean, you still got to do your own data cleaning. You do got to do that. But handling your, transformations and some feature engineering. And Ryan is talking about micro versus macro for the scoring functions. It matters if you're doing multi-class classification. Basically, it determines whether you calculate confusion matrix for all the classes summed or for each class individually. Okay, so that might be very important if you have unbalanced classes. Yeah. ISO on Twitch says, no, we need a machine learning data cleaner. Wouldn't that be nice? That's the dream, man. As far as I know, there's not a good one yet. ISO says, then we can all get fired. I think there's still room for hand done stuff, and will be for the medium near future. We talked about this in the interview with Kwakla quite a bit. Okay, so I think I've got a pretty good understanding of what it's doing now, so let's give it a try. We've got this example. So first of all, I'm going to get rid of all this information. Goodbye. All right, so this we need. Please work. Oh, fantastic, it works. A little peek behind the curtain. I've been trying to get AutoXGBoost installed in Kaggle kernels for quite a while, last week, and it's not, and it's really frustrating. Okay, so we have the iris data set here. If you're not familiar, it's a open source data set that people use for a lot of examples in machine learning, where you have different measurements of different parts of iris flowers and also the species of the iris flower, and your job is to figure out what the species is given the sepal and petal and, I don't know, calyx measurements, whatever it is they're measuring. So Jan says, it looks so easy and fun watching her explain, but not so when one is actually trying to figure this stuff out later by oneself. I mean, we haven't gotten to bugs yet. We'll get there. And this is, if I'm working with a new tool, this is what I'll do. I'll just like sit down and read the documentation. Usually not allowed. I think my office mates would not appreciate that. But I'll just sit down and read the documentation and be like, okay, this does that, this does that, this does that. And that helps me get like a good mental model of what's going on. So a little bit more coffee. Okay, and then we're doing our testing training split using the eponymous scikit-learn thing, and then we're going to look at the shapes. So in our training data, we have 112 examples of 4 classes. No, 112 examples with 4 features. Our testing data has 38 with 4 features. And then our training data has... No, these are the labels. We have 112 labels, and then we have 38 labels. I was like, that can't be right. So train, test, test. Okay, that makes sense. And now I'm going to go get a snack while my model runs. Okay, so what are we doing here? So we are training this TPOT classifier. We're going to do it for 8 generations. The population size is going to be 50. So every generation, we're going to generate 50 new candidate pipelines. And then it's going to rank them and then pick the top 50 out of the whole 100, get rid of the bottom 50, and then the next generation is going to generate 50 new ones. Okay, so it looked like that timeline where it was like 2 minutes would be 2 minutes per generation. And it's doing 2 pipelines, 1 pipeline per second. And it looks like this is sort of jiggling quite a bit because I'm guessing the different pipelines take different amounts of time to run. ISO says, I can usually almost get the library installed on my own. That's an excellent first step. Yeah, I'm in dependency hell right now. It's fine. It's fine. I'll figure it out. But it'll take a while. All right, so, well, this is running. Let's see a little bit more information. So my question is, we have this data science survey, and if we look at, I'm probably just going to use the multiple choice ones. I could do some NLP to use the free form responses, but I'm probably not going to this time. We do have to do a little bit of data cleaning to be able to use this data. So let's look at each column. So this is just how long it took the person to finish the survey. And this is something that we use to be like, you're a bot. No one takes a survey in half a second. Nice try. Is that sort of string. This should not be a string. Gender's a string. And then we have also this structure here where if there's a free text other response, then we have for that a second question column with the text of that response. ISO says, is it running local or on their server? Based on our usage of compute, I'm going to say probably locally, so in this VM. So, I mean, yes, this is being run on a server somewhere that's not this computer that I'm using right now, but I don't think it's being run on like the TPOT servers, which the H2O stuff is. I'm pretty sure it connects to an H2O server. Definitely the driverless AI. I'm not 100% sure about the AutoML, which I've just sort of messed around with a little bit. All right. And we might hit early stopping soon because it looks like we're not really seeing additional improvements on each round. Let's actually check. What's the default max eval time minutes? Early stop equals none. Oh, do we need to specify that we want to do early stopping if it doesn't improve each time? How many generations? Okay, yeah, so we're not actually going to get early stopping because we didn't specify a certain number of rounds to do early stopping by. I probably would. In general, AutoML tends to be more computationally intensive than just running a single model. The thing that you get from it is that it's probably, I mean, depending on how good you are at parameter tuning, hyperparameter tuning, it might be better than manually hyperparameter tuning many different models to get to a parameter set that's good for you. So if it's a time savings there, that's good. But the downside is that it does take a while, and it can be expensive. If you're training big models, especially neural architecture search, is pretty much the most expensive thing you can do in terms of machine learning. Maybe like really big reinforcement learning would also be pretty expensive. I mean, like anything you make big, but generally, I think the trunks are mostly neural architecture search. Which, I mean, doing neural architecture search on the Iris dataset would be like using an enormous pickup truck to move a deck of cards. Like, completely unnecessary. No reason to do that whatsoever at all, and an enormous waste of resources and time. All right. Okay, so thinking about the data cleaning we're gonna do, we already have quite a few categorical features. And some of them we are going to want to remove for job titles. So, for example, I don't want gender to be involved in any way at all in determining what my job title should be. There's on these results, there's a really sort of frustrating. I mean, it's high quality code, but there's a project where someone wrote like a salary guesser, like what should your salary be, and like gives you like a little score on your data science skills, and saying that you are male rather than female is worth like 50 points on this data science skills score, not because men are better at data science or anything like that, but just because of the imbalances in the data, which is frustrating. And Peter is ISO and has moved from Twitch to YouTube. Welcome. Ryan is saying, oh yeah, that's right, Ryan works for H2O now. So I guess I can ask you all my questions. So some questions. Kushigara says, it seems the first generation is taking 100 iterations. Any particular reason for that? Yes, because you start with 50 pipelines. Each generation you generate 50 pipelines. You evaluate all of them. You rank all of them. You take the best 50. The next generation, you have that 50. You generate additional 50, etc. So it's going to do 100. It has to evaluate 100 pipelines every time. Excellent question. And then Ryan says, both H2O options actually get deployed on your own system. Oh, that's good to know. For some reason, I thought it was on the H2O servers. People saying, yikes. I'm assuming the big yikes is about AutoML or neural architecture search for Iris. I don't know why you do that. Vijay says you should check out Hunga Bunga classifier. It's sort of a questionable name. It brute forces every sklearn model on the dataset. Noted. Is it done? It's done. Excellent. And it looks like we haven't gotten literally any improvement since generation 1. So, I think I would probably do early stopping if I were to do this further on. And then we have a best pipeline. So the best pipeline is you take the input matrix, you use a maximum absolute scalar, and then a min-max scalar, and then you use k nearest neighbors classification, where the number of neighbors is 67. P is 2. I don't know what P would be in a K and N. What would P be? I have no idea what P would be. And the weights are distance in this, what, 4-dimensional space. Do, and then accuracy is like so. And then we can export. All right. And then we should be able to cat TPOT. There we go. So we should be able to just cat the little pipeline we did. So we can see that we have all of our imports and everything. Make sure that the class is labeled target in the data file. And then here you would need to add your own path to data file and then column separator if you were doing like semicolon or whatever. And then here's your pipeline. So that's pretty straightforward, actually. I am on board for that. My question now is, how well is it going to work in a different problem? Oh, thank you. Akash is saying what P is in k nearest neighbors. It's the power parameter for Minkowski metric. When P equals 1, this is equivalent to using Manhattan distance and L1 and Euclidean distance L2 for P equals 2. For arbitrary P, Minkowski distance L underscore P is used. Okay, so it's whether you're sort of moving so or so to get to your distance calculations, which is how the weights are calculated. So I'm guessing that you would only need this if you were using distance as your weights, and if you were using something else as weights, you wouldn't necessarily need this scaling parameter or this the specification. And then so we're using Euclidean distance. Okay, helpful. I'm trying to decide. Oh, about the gender stuff. Yeah. So Peter had said, yikes about the model to predict pay being trained on data resulting from gender pay discrimination, furthering gender pay discrimination. Yeah. Yep. Anyway, things that I think about quite a bit. So we've got this working thanks to the very helpful did I upvote this kernel? The kernel I forked from? I don't want to lose this, but I am definitely going to go back and upvote that kernel if I didn't do it. Ryan says, I'm a big fan of Hunga Bunga, haha, definitely worth a look just to appreciate its absurdity. All right, maybe we'll look at that next week. For now, I think we're going to have to do some data cleaning. Everybody's favorite. Because it looks like TPOT's... Well, let's see. Can TPOT handle categorical data? Category. And I believe category is like a... nope. 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 All right. Helpful. R says, what's her name? I'm assuming I'm Dr. Rachel Tapman. Hello. Oh, yep. Sometimes I put it in the video description. This time I did not. Whoopsie. All right. So my question is, TPOT with code, TPOT on the configurations, template. They aren't intended to run for only a few minutes. They can take a long time to finish their search. Understatement. Can recommend different solutions for the same data set. Absolutely true. Code. My question is, can I hand it categorical variables, or do I need to do my encoding myself? It would be great if I had an example that wasn't with Iris. It would be great if I had an example with something with I'm going to assume it needs numbers, is my guess. And regardless, we should probably do a little bit of data cleaning to, what is it, 2018? Regardless, we should do a little bit of data cleaning to make sure that we're only using features that you would actually want to use in this situation. So add, and let's try that. All right. Gotta restart the VM. Beep boop boop. All right. So what I'm gonna do is first I'm gonna add an early stopping parameter because why wouldn't you? Was it early underscore topping? Tell me. Back to the API, everyone. Early stop, not early stopping. And the reason that tab complete isn't working is because I haven't read in the library yet. And let's say 2. I think 2 is fine. Yeah. I was gonna say 1, but I think 2 is a little bit better because you might have no improvement on one round and then actually get improvement on the next. But if you have 2, you're probably not going anywhere. It's just my feeling on the matter. Okay, so and I'm going to just entirely get rid of, excuse me, goodbye. Peace out. I'm going to get rid of all of this iris stuff. Actually, no, because I'm going to use it as a template for how I clean my own data. Okay, so other things that we need. I'm going to do all my imports in a new cell. We need to import pandas as PD. I might import categorical encoder, and I don't remember how that's... Pretty sure there's a notebook on it. Categorical encoder. This one? I don't think this is it. Nope. Nope, that's not it. Let's see. CE, I think? Encoder. See if that gets us anything. Nope. Do you like the goose? He's got binoculars. Maybe categorical underscore encoder? Yeah, nope, absolutely not. Also, I'm probably misspelling categorical encoder. Okay, so there's definitely, I don't remember. People talking about Pingu. Oh, is that the little penguin that's claymated that goes noot noot? Is that one? Do you know about things? Aha! Category encoders. Not categorical encoders. Mystery solved. Thank you, tab complete. Okay. So I do probably actually want to use that because we're going to have some categories that we do want to encode like so. Some of them are going to want to encode one hot, like skill sets probably. Some of them we're probably going to want to encode as... what's the other one? Where each one gets a number. Forget what that's called. And some of them we're probably going to want to just convert to numerics, like salary. So salary bands, I'd probably take the lowest number in the band because that's probably what they're going to say in the job ad. Basically, I want to help people write job ads good. Because if you've read machine learning job ads recently, they tend to be confusing. Again says, yes, newt. Okay. Pingu. I have seen it. Is this Gustav? No, that's the cartoon penguin. Gustav doesn't really say anything. Sometimes he goes. It's sort of his warning sound. All right. And I'm just gonna import my data frame as df because I'm lazy. You need to import CSV input. It's in the input directory and it's a Kaggle survey, and then the multiple choice responses. Excellent. Does it not? Is that not the... Yeah, it's definitely because it's read CSV and not import CSV. Professional data scientist. And then let's really quickly check our data frame. So okay, so some things we have, our first row here, or our 0th row, is actually the question text. And then we have the responses to the question. And some of these we do want to get rid of. So questions that I think are going to be helpful, Q4, degree of education. And I'm just going to leave a section here. Q4 equals level of education. And obviously when writing a job ad, we don't want to include anything that, at least in the US, it would be illegal to discriminate against. Like age would definitely be illegal, gender 100% illegal. I think national origin is illegal. I think that's one of those ones that's a protected characteristic. And I'm just going to assume maybe more homogeneity between countries in terms of job titles than actually exists. But we'll just do it. People are like read_CSV. Smitchan says it's called a dummy variable. Label encoder, that's the one. Yep, thank you. And people are like, it's read CSV, thank you. There's a little bit of a lag, I'm not ignoring you. All right, and then I think Q6 is going to be the one that is going to use as our target, because that's going to be job title. Q7 is, Q6_other_text is the other field. So if someone had written their own job title, and I'm actually going to ignore that so that we don't have an insanely multi-class problem, and then we have a pretty manageable number of classes. What else do we want? 7, industry. I think that's absolutely important, because you're going to be probably in finance and tech, names are going to be slightly different. Industry employment. And actually we could probably do this in the data set itself while we're taking notes. Oh, actually, what would be easier would be, hopefully everyone can read what I'm writing. Okay, let's look at it this way. I was like, I want my beautiful data set view. As it turns out, you can get your beautiful data set view in kernels. We added that. Okay. So other things, Q5 is what your education was in, and I honestly don't think that's especially relevant for a lot of data science jobs. There's a lot of astrophysicists in data science. There's a lot of fisheries, at least in Seattle. There's a lot of people from fisheries and data science who made that transition. There's a lot of people with, undergraduate degrees in English and linguistics and data science. There aren't that many, but there are some. So I think that we can ignore. And then Q7 is industry. All right. Q8 is, I think, actually, I think a different view is going to be helpful. I think we do want to see the first couple rows. Okay, so Q8, can I not see my other rows? I guess maybe I can't. Nope. Interesting. See, physics or astronomy, pretty common. All right, I guess we have to do it this way. So Q8 I think is years of experience, which I think is super relevant for a job ad, whether you're looking for a junior or a senior. Years of experience, so I think absolutely relevant. And then Q9 I think is compensation. 9 equals comp, and we'll want to drop I do not wish to. So we want to drop the columns that don't have compensation information. My guess would be a lot of those would be students as well, people who said that. All All right, and this is the degree to which the business uses ML methods. ML. So also probably just while I'm doing this, I might as well say how I want to encode them. Lab encoder. This probably, do I want that to be label encoded or one hot encoded? So the difference is that label encoding can, with some methods, lead to sort of a hierarchy of responses. Like one of them is, like on some degree you're saying that like education is bigger than tech or something on some axis. This one definitely, nope, make numeric. This one we can just make numeric. We're just going to need to tidy it so it actually reads as a number. Degree to which business uses ML. I think this is probably a good label encoder. This actually I probably do want to be one hot. Because you can also imagine in an industry, you might also imagine a business that is like, hey, we work in agriculture and technology and manufacturing or something. Like if they build, tractors these days are like super duper computerized. So if you produce tractors, if you're working for like New Holland or John Deere or something, that might be, you might want to say that you belong to multiple industries. So I think one hot is probably the best choice there. Q11, product or business decisions, role at work. Role at work. Okay, so Q11, all of the different parts, all parts to one hot. And it looks like there actually already are, it looks like they actually are already one hot encoded, so we just need to tidy them up a bit. And this is the things that people do in their role at work, which I think would also be very important for drop other text. Would also be very important for deciding what a job role should be. Q12, and I know that this is like going through things and doing things by hand, but that's the job. Figuring out which should probably be important. Dev environment, probably not something that's going to be a deal breaker for somebody working at a job. Q4, Q5, text. Dev environment, select all that apply. Worker school, okay, and then this one is, oh, okay, oh, actually, I think this probably is very important. So this one, I'm pretty sure that whatever, Q12 is tools used in job, and I think that we probably do want to be one hot. Because one thing with label encoding is if you have one column and then like agriculture is 1 and tech is 2 and education is 3, you only get one of those numbers, where with one hot you can have overlap. So that one I think would probably be a good one for one hot. Q2, Q13, IDEs. This is the one that I think is probably not going to be a deal breaker. Different types of notebooks, again, I don't think super important for deciding what the job should be. Services, have you used things like Azure, GCP, AWS? I think that is actually probably pretty important for some jobs, because I can like use a different IDE. That's not a huge deal. I cannot be on a different cloud than the rest of my team. That's not ideal. That's a little bit hard to do. Please interview Michael Nielsen. I don't know who that is. I'll have to look into that. Should we worry if one hot encoding can lead to overfitting since it creates a large number of features? It depends. Yes, it can lead to overfitting. I would say like be conscious of what you are choosing and don't default to one encoding for everything, just from in general. Enrique says, I didn't reply to the survey, so sorry. Oh, it's still going on. So this is for the 2018 survey from last year. The 2019 survey, which we're currently doing, is still happening. So you got your chance if you wanna be counted. I love filling out surveys. So every time somebody's like, will you do a survey? I'm like, absolutely. Always make sure to do the Stack Overflow one as well. Cloud services. So that one we probably do want to include. All right, 16. Programming languages, again, probably something you want to include if you're in a Java shop and you're like, I only use Python. That's going to be rough for you. That's going to be probably something that you want to know before going into that job. Programming languages. Or if you're like working in aviation, you do need to know Fortran, because all of the aviation databases are in Fortran. My mom programmed in Fortran, and every so often she'll get a recruiter call being like, hey, you want to come back? You want to work on Fortran again? Python R. Oh, I think this is the one where which would you recommend for beginners? I think that one we can do. Deep learning frameworks. I don't know how important that is. Maybe. Again, if you're coming into a shop and like they only use TensorFlow, also probably you should use TensorFlow. But I think once you have a good understanding of deep learning, it's pretty portable between frameworks. Yeah, and also they change so rapidly that I don't know that. Well, I mean, we do the survey every year. Might as well include it. Frameworks. Oh, and that's the last one. Okay. So this one should probably be one hot. Because again, programming languages should probably be one hot, and then cloud services should probably be one hot. So we're probably going to end up with quite a few different features, because you can see like question 19 has 12 parts. So that's 12 features from one question, because we are doing one hot encoding, which creates a new column for every feature. So nothing about that says one hot encoding isn't always better with tree-based methods. Sometimes just pure factorization works better. Yeah, and I suppose that's one of the things that you could experiment with here. I just think for this particular problem, I think it might be the most helpful. I could be wrong. We'll find out. Robbie says, why should you take a data scientist with you into the jungle? Answer, they can take care of Python problems. Oh, Pythons are fine. Especially ball Pythons. They're not going to hurt you. I like Pythons quite a lot. If it were allowed in my lease, I would definitely get a snake. Good at interpreting random. Abhishek says, Pythons are good at interpreting random forests. All right, and SN says about different libraries, they copy each other enough that it's easy to swap. Yeah, and I would say it's more important to build like a good understanding of what different architectures are doing than to be like, I know TensorFlow very deeply. Not that it's bad to know TensorFlow very deeply, but. All right, so I'm going to wrap it up here because I got to run to another meeting today, unfortunately. And I think what we will do next week is spend a little bit time doing data cleaning, getting going with this problem, getting to the point where we can take this data frame and pass it on to different AutoML frameworks. And I want to just try out a bunch of them, see what I like, see like pros and cons of each. So far TPOT ran really quickly, which has not been the case with AutoXGBoost, which, to be fair, TPOT is in our Docker image and AutoXGBoost isn't, and I should probably make a pull request to get that added. But it was very easy to use on Kaggle, so that's a plus. And I do like that it gives you, I got rid of it. I do like that it gives you the Python code for your pipeline out. That seems very useful, and also a very, something that I could then modify as needed as things change. So, all right. Thank you for joining, everybody. Amber says, it's great. Please do a video on the squad dataset. We've talked about it quite a bit in the different papers that use glue. So I would check out some of the reading group papers. And I will see you all next Wednesday for paper reading. And I won't be in on next Friday, because I am going to be at my cousin's wedding. But I don't know, maybe I'll record something. We'll see. But definitely, next Wednesday, we're going to keep working on EfficientNet, which has been a really interesting paper so far, and also uses AutoML. So if you're interested in AutoML generally, hop in for that paper. All right. Thank you so much, everybody. I hope you have a great weekend, and I will see you on Kaggle. Bye.